Good afternoon, everyone. Welcome to the weekly GEO presentation. So today I'm going to present you about. I'm going to give a small introduction to you about Websockets and an introduction to SignalR. So I guess most of you guys might have heard about Websockets. It's kind of a new technology. So today in the modern world, all of us live in a very highly paced world. It's a very fast-paced world, and we require things to happen immediately. We want everything right now, whenever it happens. So, as the internet has also evolved, the internet technologies and web technologies has also evolved. These technologies has also evolved in a way to support our needs. So, WebSockets is a technology that supports true real-time communication. So, up till now, we might have had real-time experiences. For example, we might have had dashboards, or we might have had other real-time chat or maybe online gaming, which appears to be very real-time. But the technology behind that was not real-time, technically real-time. But through WebSockets, we are able to achieve that now. So let's move on. So this is what I'll be doing today. So I'll be just giving you a small introduction on what WebSockets are. And also the protocol handshake of a WebSocket, so how to establish the connection. And then how do we get things done before WebSockets? So some of the old technologies or some of the ways that we achieve similar real-time communication. And also, I'm going to give a small comparison between polling versus WebSockets. So polling is a technology that is, or a method that is used to achieve something like a real-time communication. And also then we come to applications of WebSocket. And then I'm going to give a small introduction of SignalR, and which will be followed by a demo. And also the users of SignalR, which is mainly the applications of WebSockets as well. And then if you all have any questions, to go about with the questions. So when it comes to what WebSockets are, WebSockets is a protocol providing full duplex communication channels over a single TCP connection. So it offers connection. It offers a both persistent and a long-lived, that is a long-lived and full duplex communication, which means that both parties connected to this connection can communicate over this channel. So that means the server also can communicate to the client whenever it wants, and the client also can communicate with the server whenever it wants. So usually we have just heard about the client requesting something from the server and the server responding. We have not heard much about, or we are used to the concept or the idea of the server directly pushing data towards the client. So through WebSockets, we are able to achieve this. So let's see in further slides how it is achieved. To establish a WebSocket connection, it starts off as a normal HTTP connection. So this is advantageous because a normal browser or server can listen for a normal HTTP request and a WebSocket request over a single port. So we don't need to define a special port there. But once the protocol takes place, once the response takes place, once the connection is established, then it is completely different to an HTTP communication process. So if you look at the screen on your left-hand side, that is the connection header that is set by that is the handshake that is established by the browser first initially. So here you can see that it is actually an upgrade request. In that upgrade tag we have it says that WebSocket. To say that I want to connect to a WebSocket, it requests the server for a WebSocket connection. And also, once it is done, the server also responds with a WebSocket saying that it supports WebSocket. So this is the handshake for the WebSocket. Once this is established, there is a connection between the server and the client, whichever client that requests a connection with the server. So this connection is a full duplex connection channel where messages can be passed up and down. So and also along with the header, a secure WebSocket key is being sent. This is which is actually a base64 encoded key. The reason for sending this key is to prevent caching, any caching proxies resending a previous conversation. So each time a new key is sent, so what the server does is it will get the hash of that base 64 which was sent. So to ensure that there is no previous messages are being resent again, to avoid this, a secure WebSocket key is also being sent. So this is nothing to do with security or anything. This is just to overcome the caching problem. So initially, during the initial stages, a lot of developers, a lot of people did not want to go towards WebSockets due to some security issues, due to scalability issues. But now in the latest versions, all those problems have been overcome. So the security issues and all those issues have been overcome. So that's why you can see that a lot of applications these days, which require real-time communication, tend to use WebSockets. So how did we get things done before WebSockets? So one of the ways to get it done is using polling. So polling is basically it's like sending an HTTP request. It's like a refresh, very similar to a manual refresh. So what happens is when we want to get information, we send a request to the server in a specific time period. So for example, we will check if there is new information at the server every 5 seconds. So when we use polling, there is a large overhead because each 5 seconds the browser has to contact the server and check whether there is any information. If there is no information, it will be just returned. Again, you have to check. So this keeps on happening. So another technology is long polling, which is slightly better than polling, or I should say much better than long polling. Here too, it establishes an HTTP request to the server, but if there is any new information, the server does not return it, but it will hold on to the connection until there is new data available. So as soon as the new data is available, it will respond to the client with this new data, and once it gets the data, so that means the HTTP request is complete. As soon as the client receives the data, it will again immediately fire another request. So this will kind of keep this connection between the server and client to a long time, which kind of it's kind of like a hack, or it's like tricking the system to say that it has a very real-time communication. So it's something like that. So another one is server sentiment. Yeah, sorry. So it has also a timeout. So if there is no any information within that timeout, so it will time out and it will again have a new request. So why I said that it is better than polling was, so when timeout does not always happen. If there is any information that is useful, any new information, it will get the information. So that is the advantage of long polling over polling. So server sent events is it's where a client will request the browser, the server, and the server will create an open communication with the client, and it will not close, and it will execute scripts on the client with new information. So now here the server has a real-time communication with the client, but not the other way around. So this also is not duplex, but here also you can achieve something to real-time communication, because the server can execute scripts on the client because it maintains an open connection with the client. So these are some of the technologies or methods that were used to achieve real-time communication before WebSockets. So these are two code examples of polling and non-polling, which I have just put for information. Okay. So what is the difference between polling and WebSockets? So polling is basically the best way I can imagine this is to imagine an annoying kid, right? So what they do is they keep on pestering parents for something. For example, say a small kid wants chocolate or something. So what that kid will do is they will just keep on pestering the parents, give me chocolate, give me chocolate, give me chocolate, and keep on pestering, right? So this is also something like that. So the client keeps on pestering the browser for new information. Have you got any information? Have you got any information? Do you have data? Keeps on calling for data, whether it has data or not. So in polling that will happen. But in WebSockets, that's not the case. So first the client will check whether the browser the server supports WebSockets, and if it does, WebSocket communication is established, and thereafter it's free. Like both sides can communicate with each other. So it's kind of like remote procedure calls. So the client can send data to the browser can send data to the server, and the server also can send data to the client, and there is no latency whatsoever, because it's actually real-time communication. So this is the real-time communication established here, and the channel is duplex, so both sides can send events. Alright. So applications of WebSockets. So especially social feeds these days. Facebook also uses this on that the side panel, which keeps on updating with the latest events of your friends, whether if it's a like or a comment or whatever. That also uses WebSockets. Social feeds like that, or multiplayer games. A lot of multiplayer games these days using HTML5 use WebSockets. Then there's collaborative editing and coding. So places like when you need to edit a document together, or you need to code together, you can get real-time information without being, for example, if you take Git, what it does is it manages branches, right? But if for example, if there are two people working on the same branch, until the person pushes the branch to the central repository and I pull it back, I would know what the changes he has made, the other person has made. But if there is some coding environment established with WebSockets, two people can be working on the same branch, and both of us will know exactly what each other are doing, because you can have real-time communication there. So collaborative environments like that, and also clickstream data. So here, usually when people, especially for marketing purposes, people gather intelligence of information from clients, how they use these websites, like where they click, what is their searches, things like that. But here you can't be very expensive with the data that you track, because it's a huge overhead to gather a lot of intelligence or to gather a lot of data, right? But with something like WebSockets, if you want to track the mouse movements of the client or the person who is browsing, you can do that, because the overhead is very low and you can get real-time information. So clickstream data like this. And also financial tickers, so especially for stock markets, where you need real-time information, you can use WebSockets. Then dashboards and monitoring, again you can use, or sports updates like Click Info or something like that. You can use multimedia chats and location-based apps for tracking, or for sports purposes. You can do that. You can just connect. You can send your GPS information to a server, and you can track the movements of maybe a vehicle or a sportsman or whatever in real time. There is no latency here. And also another important area is online education, where students and teachers will be able to interact in true real time. So the biggest advantage here is that less latency and less overhead, cost overhead. So coming to SignalR. So SignalR is a .NET open source library which supports real-time communication. So I wouldn't say that this is a technology to implement WebSockets, because I'll explain to you why later on. But this mainly uses WebSockets to achieve real-time communication, and it simplifies the process. It's very easy to use and implement. You don't need to study a lot to do that. It's very easy to start up and implement this in your projects. So when we do the demo, I'll show you. I'll explain to you what are the basic things that we need in order to use a SignalR, in order to use SignalR in our projects. And also SignalR handles connection management automatically. So you can, if you want to send messages to all clients that are connected to a server, you can do that, or specific clients, or you can manage the connection the way you want. So it has that flexibility as well. So before I go to WebSockets versus SignalR, to explain to you what's the difference between WebSocket and SignalR, I would like to go ahead with the demo now. So for the demo, I have created a simple chat application, which is also a lot of examples are available for reference on the internet. So here This is the server-side code. This is what we require for the server-side. Hub is it's a high-level abstraction of the SignalR, which handles all these connections and which acts as the hub. So chat hub is my class, which extends the hub class of SignalR. And here I write a server end method. So send here is a method on the server, right? So here this method accepts 3 parameters with an optional parameter at the end. So a name, a message, and an ID. So what I am trying to do here is to create a chat application. So I need the name of who the sender is, and the message what it is, and an ID which I have kept it as optional for some reasons. So here, if the ID is null, I want to if the ID is not null, I want to broadcast it to all people except the sender. If it is null, then I want to broadcast it to all. So depending on how I call it, I can get it. I can get the output. So here, add new message to page is not a method on the server. This method that is being called here, add new message to page, is a method actually which is on the browser. This is a method that is available on the JavaScript. So this client's object, it's a dynamic object. So it is not there right now, but once the application is up and running, it will be created. So basically, this is all the server-side code you need for a SignalR application. So there is a server send, there is a method that a client calls of the server. So this send method will be called by the client, and once the client calls this method, the server does some action. So in this case, the server calls a method on the client, which is in JavaScript. So I'll show this add new message to page on my client on the CSS/HTML page. So there is just a small heading to say chat and a container to have a small text box and a send button to get the arguments. And here is the JavaScript code. So for SignalR to work, so you need to include the SignalR jQuery.SignalR reference, which you can get by NuGet. If you import the package from NuGet, you get all these references. So you need to refer the script, which will be handling all the SignalR related code. So you need jQuery for this to work. So since it's being referred in the layout page, I have not referred it here. So you need jQuery for this to work. And this is the important part. It's kind of like it's like magic, because this particular SignalR/hubs is not a script that is existing right now. This is a script that will be created dynamically for you. It's kind of a proxy to the server. So you can actually ignore this as well, but having this simplifies your life very much. So I'll explain it to you when I show that, when I demonstrate that aspect as well. So this is, so far there is no reference like this, and there is no physical file like this right now. But there are ways actually where you can create physical files. You can create a specific file for all this. There are options like that, but I'm not going to go into all those today. So sorry.
It's generating like a starting RPC. Is it generating some actual files?
Yes, it's generating files at the runtime. So when it is running, so I'll be showing that file once it is being once the program is executing. You can view it from the console, the browser console. So for example, first of all, you have to create a connection to your server hub. So here, $.connection is a reference in SignalR, the jQuery.SignalR. So that is so using that, I create a connection to the chat hub. So chat hub here is the chat hub class that I created here. So you all might know that the chat hub class here is in Pascal case, but here it's in camel case. So that's a convention followed in SignalR. So though it's in camel case, this refers to the server side class that I have created. Alright, so we'll just ignore this bit of line for now. It's just for logging purposes where I'll be making use of it later. So that's basically how we establish a connection or define a connection. And now this is the method name that I have called from my server end. So this method actually here is where I'm defining it. This is the function that I'm defining. So I assign this function to this variable. So chat is the connection. So chat.client.addMessage to page is the procedure or the method or the function that is being called from the server side. So this function resides on the client. So this is not on the server. So here what I do is get some messages, get a message and append it to create a chat list. It will go on. So that's what happens here. And also I've added some code to initially get the name of the person who is connecting to send it along with the chat message. And also this is how you start a connection. So you refer your connection to, which is the refer connection to the server and start it. And this is a promise saying that once the connection is started, once the connection is done, you follow with the rest of the functions. So once the connection is done, you register the other jQuery functions which handle the click event of the button, and also which thereafter the rest of the work which ultimately send messages to the server. So here you can see that I have called chat.server.send. This is here what I'm doing is I'm invoking a method on the client on the server. So having this proxy reference here actually simplifies things. So I have also another sample page which has information without a proxy hub. So you can see that there is no. I have just referenced the SignalR script here. So if I don't use the SignalR script here, I have to specifically add function names and pass it as a parameter. But here you can call server side events as though it is on the client side as well. So I have invoked this send method which is on the server as though it is in the front end. So it makes things easier. If it is not the case, I'm able to do this because of this proxy. If I don't have that, I'll have to invoke this send method, and it is kind of passed like an argument into this invoke method. So it's basically a matter of difference of coding or conventions of coding, but I find that this way is more cool. So it actually makes you feel that you have a true connection with the server. You can just kind of directly call methods in the server without like calling a normal method on your client end. So here what I do is once the connection is started, this function is registered. Here once the click button is clicked, the send method is invoked and two arguments are passed in this case. So since the third, these are the two parameters that match to these, name and message. The third parameter is optional. So I am just passing two messages in the first demonstration, and that's how this will work. Alright, so addition to that, so there is an image grid, so I have set up the other controllers and what needs to be invoked when I run the demo. So these are the two methods that I am mainly interested in, controller methods. So I have created one called chat and one called chat np. So chat is the normal chat, and chat np would be the chat without proxies. I have just created to demonstrate that you can do it in this way as well. And also in the startup, you have to you can map if you have any paths until and then you can map it here. Here I have added an enable JSONP2 for a reason to demonstrate to you all cross domain capability. I I think 2 weeks ago or 3 weeks ago, software explained about cross-domain restriction. So here too in SignalR, to enable that, to avoid that restrictions, also you can use two ways. So one is using the using cores with JSONP. So that's why I have put it here. But for now, I'll just comment it. Okay, so we are good to go for the demo. So I'm going to alright. Just give me a minute. So these are two different browsers. So this is to demonstrate that these are two instances. Even if there was another machine connected with the server, you can open it and you will be able to request instant communication. So I'll just send something hello here. Just give it. So I need this in here. No problem. It says that it has started WebSocket connection, but for some reason there was an error. Okay, there's a server error invoking the send method here. I'll just check what it is.
does it work in the file path? Like, do you need to post it on a web server?
No, so this is work when cross domain is established. So this is an example I created to show later on, but I was just thinking, trying to figure out where the issue was. I just ran this program before I came here to the hacking server. Just thinking I might have changed something. Sorry about it, just a few seconds, I'll try to figure it out. Okay, so for some funny reason that I can't figure out right now, the code that I wrote without the proxy, that is this chat np, which is under this chat np controller, is working, and the one with the proxy is not working. Actually, it should have been the other way around, because this is a bit messy to write, but that is much easier to write. So here, the difference between these two, with the proxy and without the proxy, is that as I showed you earlier, without the proxy, you can just call server-side methods as normally as it was. Here, you have to send it as a parameter. So I'll just demonstrate what is working right now. So here, the control is chat np. No, because this is an optional parameter, so I don't think it is because of that. I don't think there can be an error because of that. So I'll just check that as well here. Apparently that is the reason. Okay, so I don't know why that happened there. But anyway, this is how it will work. So here there are basically two instances of the same browser. So here I say hello, and it will go on to it will appear in the other screen. So we can even open another, say maybe a third window as well. I'll just copy this URL over here. So you can see that. So now someone said hi, and it appears on both the other two windows. So I say okay, hello or something. So once I say send, it will instantly appear in the other two. So here the reason is I have I have defined in this send method to say that clients all accept and the passed ID. So the ID that I am passing is my own ID. So except my ID, the others will be sent. You can actually send a string, an array of IDs to either exclude or to include users, specific users that need to be sent messages, or that need to be the messages need to be restricted, something like that. And also there are some other functions as well, all except all. There are some others. So there are some methods available that we can use to control to whom we send these messages. So because of that problem, so I think I've demonstrated two aspects of which I wanted to demonstrate. One is with the proxy and one without the proxy. And also now I'll show you where this proxy is generated. So once you go to network, so this is the SignalR folder. In this folder, this is the hub that is generated dynamically. So you can say that if you say here that so here is where this will generate, this will register my send method, which is on the server or on the client side. So this can happen only after it is created, because before it is created, the JavaScript does not know what the functions in the server are, right? So this is where that happens in this using the proxy. Otherwise, we'll have to specifically send the name along the invoke method if you don't have that proxy. That's what I have done here. Here I have sent the method name in the server as a parameter to the invoke method, which is defined in the SignalR library. Alright, so now I'll also demonstrate another aspect of SignalR where it will enable us to use this even over cross domains. So this is another same file that I have written and saved in another location. So when if I run this in the browser, what will happen is it will act as though another domain. So this should also work. So to make this work, I had to send this JSONP true. So in this case, it will start not a WebSocket communication but a long calling communication. You can also start have WebSocket depending on whether the browser supports it or not. So here I am going to show an example of long calling. So this is the advantage of WebSocket is that it doesn't of SignalR is that it does not just rely only on WebSockets. It has a lot of other fallback plans as well that has been implemented. So when we write code to achieve something in real time, we don't need to worry about whether it is being supported by browsers or supported by servers. We don't need to worry about those things because all of that those have been taken care by SignalR. So now I'll open this file. So here I give a name. So this entirely didn't go there. Okay, here, okay, I have to put the parameter here, sorry, again. Okay, so I'll refresh this page again.
Did you save it? Did you save the text?
Yes. So, thanks. So we can say that the new this is in the C drive. This is not in the not hosted in the server, the local host. But here too, the messages that I sent, the message that I sent has gone here. You will be able to see it in all browsers as well. There are 4 browsers, so you can see that it has gone everywhere.
So how does that work? Like, this page, is it just a page in your
yeah, but it references yes, it references the SignalR library here, and here I have to give the connection URL. When I make the connection, I have to explicitly give the URL to connect, so that it will be able to connect to the exact server. So that is the difference that we'll have to make here, and also regarding the JSON-P. And also when you use JSON-P, another feature that is interesting is that here it will use long polling. So here you can see that we are able to view all these logs because of this piece of code here, which I said that the connection not logging true. That's why we are able to see all the logs here. So in this case, where it comes from the where it is not on the same domain, when I use JSON-P, it uses long polling here. So I'll just send something else. It invoke chat hub, and it will open another long polling connection. So when but in this case, it is Websockets. Here you can see that earlier on a WebSocket has been opened, and that WebSocket connection is what is being used.
Can we see the WebSocket activity in the network tab?
Yes.
Is it able to trace it? Send or receive message.
So the reason I think is because this WebSockets is not like normal HTTP. It's a separate protocol. So, but in this case, you are going to see some network activity because now where it is not on the server, it uses long polling. So it's again like a normal Ajax polling request. All right. Okay, so let me get back to the present. There are a few more, just a few other features that I would like to demonstrate as well. So we'll see you once we continue the presentation. So here, So here the difference between WebSocket versus SignalR is, as I mentioned earlier, is that the advantage you get of the need of doing less work. So normally when you write a WebSocket application or program for WebSockets, what happens is you will have to consider about support of browsers, support from the server, and all of these things need to be, so in the event of what if something does not support, and some clients do support it and some clients don't support it, what do you do? So all of these things need to be taken care of. So developing code there, get into there might be errors there. It's all your own work and you have to do all the hard work. But in SignalR, that is not the case. It has other fallback mechanisms. So if WebSockets is not available or is not supported, or for some case, as in my example, if a JSON-P parameter set as true, it will fall back to other methods like long polling or to server sentiments, and so on. It will go on. So that is the beauty of SignalR here. So it's not exactly WebSockets, but it will ensure that you will get real-time communication, and it also will ensure that your program will not crash. And also, it automatically has some legacy support, so you don't need to worry about old browsers as well. So most of the almost all the old browsers support polling or long polling technologies like that. So that is the beauty of SignalR here, and that is the difference between SignalR and using just normal WebSockets, writing your own code.
So SignalR seems to have jQuery dependency.
Yes, yes.
Is there an Angular version of SignalR?
I haven't looked into it, so I'm not sure about it. So, so these are the transports and fallback methods of SignalR that I told you earlier, that I was talking about earlier. So depending on the version of the browser, it will use long polling, or if the JSONP is configured to be true, it will again use long polling. So which I demonstrated earlier. If it's a cross-domain connection, also it can use WebSockets if the client supports CORS, so cross-origin resource sharing. And also all these three conditions have to be met, where the client also needs to support WebSockets, server also needs to support WebSockets, as well as the client needs to support CORS. So if any of these criteria are not met, in the event of a cross-domain access, it will fall back to long polling. And also if it is not if JSONP is false and it is also not cross-domain, then it will use WebSockets. So that so because that is the fastest and most reliable way here, and that is the whole point of integrating SignalR, integrating WebSockets into SignalR, right? So most of the time, so your first option or your first priority or your first preference would be to use WebSockets. If it is not available, you can fall back to all these other technologies available. So if client or the server does not support WebSocket, then server sent events will be used. If server sent events also not available, then forever frame is attempted. So if forever frame also fails, then it will go to long polling. So forever frame, as far as I know, is a technology that is only supported by Internet Explorer, which kind of has an hidden iframe, and so it's similar to the server sent event. Because Internet Explorer apparently does not support server sent events, maybe the older versions. So here you can use some options to monitor your transports and to specify transports as well. SignalR provides you this. So the first one, connection upload logging, we saw throughout the demonstration. That's how you are able to check what type of connection it is, how whether it's long polling or WebSockets, and what are the events being called, and all those things can be monitored there. And also you can give you can explicitly say what kind of transport you use. So if you don't want WebSocket for some reason, you can specifically say to use long polling using the transport using this sending this JSON, saying that defining the transport as long polling. Or you can even give a list of fallbacks. You can define the order of fallbacks. So for example, first you can say first go on WebSockets. If that fails, go on to long polling, something like that. We can define the order of the fallback as well. So I'll just quickly demonstrate it as well. So inside the start, we'll have to define this long polling, and so if you look at the console here, you can see that now it is long polling. So now everything will happen in using long polling. So I'll just say hello. So here, this is to demonstrate that just because we don't use WebSockets, your program is not going to crash. So in the event where you have implemented this in your project, and say for example your client or some server does not support WebSockets, or for some reason WebSockets is not available, your fallback is always going to work. So this is the beauty of SignalR. It ensures that it's not going to, your program is not going to crash. And since SignalR is going to be supported throughout with all the updates and for all browsers, you don't have to really worry about what will work and what might not work. You can just concentrate on developing your program logic and going on forward from there. So that is another feature I wanted to demonstrate. So you can specify fallbacks as well. So these are the constants that you can specify the transfer or the modes of transport. So for the first one is WebSockets, or you can use forever frames, server sentiments, or long polling. You can use these string constants to specify that JSON that I sent in the JSON that I defined, which will be sent at the start method when creating a connection, defining what type of transport you want to use. So performance wise, so it can support hundreds, thousands of messages per second, and it has a very low memory overhead, and it can have, regarding scalability, it can have thousands of connections per server, and also it supports horizontal scale out using a pluggable bus backplane, which is Azure Service Bus, Redis, or SQL. You can use those things as well. So actually, when I was going through a video regarding SignalR, they said that the guys at Microsoft QA or load testing had a hard time trying to break this because it was so scalable. So they have SignalR has really been, I should say, evolved as a very robust and reliable framework or a library, which will ensure that your program works, and also it will not crash. Maybe because of, it will not crash because of technology, nor because of load. So it's very pretty robust and reliable. So how do we decide when to use SignalR? So whenever you need to refresh a page to get any information, or whenever you say you need information instantly from the server, you can use. So basically, any application where WebSockets are applied, or you need WebSockets, you can use SignalR. So these are some references that I've used, which had some very useful information. So any questions? Seven minutes more.
Someone to use SignalR in video does something other than a web application, say Windows application or Android application. Are there any libraries? Does WebSocket kind of concept?
So even for Android, if you
just use a TCP.
Yeah, even for Android, so WebSockets of course you can work, but since the client side code is in JavaScript, so you can obviously use it on Android as well, but as long as the server is in .NET. So I'm not sure whether they have support for other technologies as well, but in the case of, so especially hybrid apps, since even if it is native app, of course I'm not sure how it might work. I've not looked into it much, but if it's a hybrid app, of course there shouldn't be a problem, because it's again JavaScript and JavaScript. So alright then, thank you very much.